Alright, here we're looking at completing the square to solve. First, before we talk about completing the square, we got to first talk about a perfect square trinomial. Perfect square trinomial is a trinomial that can be expressed as the square of a binomial. So review here, if I started off with a binomial and squared it, that means to do x plus 2 times x plus 2, and then we go through and do FOIL, and we end up with this solution here. So basically, we're going to be going from this way back to that way. We need to make our equations look like this one right here. This is our basic formula we're going to be using. So for this one right here, the x squared plus 8x plus blank, in order to make this a perfect square, what do I need to put into this blank? Well, I take my 8, I divide it by 2, and I square it. I divide it by 2 because of this 2 right here. Okay? So 8 divided by 2 gives me 4, and I square that, which gives me 16. So 16 is what I would put here. So the factored form of this one would be x plus 4 squared. And that's what we're trying to do, is turn these into perfect squares. So here, looking at number 1, we need to find what goes in our blank here. So I'm going to take my coefficient here in the middle, my 4. I'm going to divide it by 2 and square it. 4 divided by 2 is 2, and I square that, so I get 4. 4 is what goes in the blank. So the factored form of this one is going to be x plus 2 squared. This number right here is always the same as this one right here that we squared. Now looking at example number 2 here though, it's a little different because we have to first take care of this. Our leading coefficient has to be 1. We can't have a 5 out there. So I have to take that 5 out. So I'm going to write the 5 in the front, parentheses, x squared minus 5x plus blank. Okay? So we factored the 5 out. Now I can make the stuff left in the parentheses into a perfect square trinomial. Okay, so my leading coefficient is 1 now, so I take my middle term, which is 5, and divide it by 2. And I square it. Well, 5 doesn't divide by 2 pretty, so I'm just going to leave it as a fraction. So this is going to be 25 over 4. 25 over 4 is what I put in my missing blank here. So when I go to put my final factored form, I have 5, parentheses, x. This time it's going to be minus because there's a minus as my middle sign. Minus, and what did I square? I squared 5 over 2. And there's the final answer. So looking at our next examples here, we're going to actually be solving our quadratic equations using completing the square. In order to do this, I need to get rid of this 35 first, because this is not a perfect square. So I'm going to subtract 35 from both sides. So I now have x squared minus 12x plus a blank here. And that's equal to negative 35 plus a blank. And I have to put a plus blank on both sides because whatever I do to one side of my equal sign, I've got to do the same thing to the other. Now I have to figure out what goes in the blank. Well, that's where I take and say 12 divided by 2 and square it. Well, 12 divided by 2 is 6, and I square that. And 6 squared is 36. So I'm going to plug a 36 into these blanks. So now on the left-hand side, I have x minus 6 squared. On the right-hand side, I have negative 35 plus 36 gives me 1. I can now solve this by taking the square root. I take the square root of x minus 6 squared. I take the square root of 1. This one leaves just x minus 6. Over here I get plus or minus 1. You got to consider both the positive and the negative version of it. Since it was a perfect square, I'm going to write x minus 6 is equal to positive 1, x minus 6 is equal to negative 1, and now solve for x for each of these individual equations. The one on the left, I do plus 6 to both sides, so I have x equals 7. The one on the right, I do plus 6 to both sides, and I have x is equal to 5. And we have just solved problem number 3. For this one right here, again, in order to do our completing the square, we need our leading coefficient to be 1. Since this is an equation, we can actually go through and divide every piece of my equation by what my leading coefficient is. In this case, it is 2. So I'm going to divide everything by 2. So I now have x squared plus x minus 12 is equal to 0. To do our completing the square, I need to move the 12 to the other side. So I'm going to do add 12. So I have x squared plus x plus blank is equal to 12 plus blank. And I need to determine what goes in that blank. Well, I take my middle coefficient, which is 1, and I divide it by 2 and square it. Well, this one does not reduce, so I'm going to take and just square that, which will be 1 over 4. So 1 over 4 is what I plug into each of the blanks. I now factor the left-hand side. It becomes x plus 1/2 squared. On the right-hand side, I have 12 plus 1/4, so that's 12 and 1/4. I want to change the right-hand side to an improper fraction because it'll be easier to deal with when we start taking square roots and whatnot. So I'm going to take and do 4 times 12 and add 1, so that gives me 49 over 4. This side has not changed. It's still x plus 1/2 squared. I now have to take the square root of both sides. So the square root of x plus 1/2 squared and the square root of 49 over 4. So on the left-hand side, we have x plus, well, I don't need the parentheses there anymore. We have x plus 1/2. On the right-hand side, the square root of 49 is 7. The square root of 4 is 2, so I have plus or minus 7/2. I can take now and write this as x plus 1/2 is equal to positive 7/2. X plus 1/2 is equal to a negative 7/2. And go and solve each of these respectively. The one on the left, I do a minus 1/2, minus 1/2. And I have x equals 6/2, which then tells me that x is equal to 3. Because 6 divided by 2 is 3. The one on the right, minus 1/2, minus 1/2. So this now tells me I have x is equal to a negative 8 over 2, which is x equals negative 4. And there are 2 solutions. Solving equations by completing the square. Good luck.